This naturalrefrigerants.com article is being read by an automated voice. Strabag building 165 megawatt Isobutane heat pump for district heating network in Mannheim, Germany. By J.O. Haraldson. Published November 5, 2025. German utility MVV Energy has commissioned Austrian construction and engineering firm Strabag to build a 165 megawatt isobutane heat pump, which will provide district heating to 40,000 households in Mannheim using the Rhine River as the heat source. INP Germany, a Römerberg-based engineering company, provided the general construction plan and preliminary design. It will be the second river source heat pump at MVV's Grosskraftwerk Mannheim facility, with the project receiving financial support from the government's Federal Funding for Efficient Heating Networks program. During the heating season, the Rhine flows at a temperature between 3 and 12 degrees Celsius, 37.4 and 53.6 degrees Fahrenheit. Compared to current standards, it will be the largest heat pump of its kind in the world, Strabag said, with the project representing €200 million, $230 million investment. The design comprises two individual modules, each with an 82.5 megawatt output, and generating temperatures up to 130 degrees Celsius, 266 degrees Fahrenheit. MVV delivers district heating via 592 kilometers, 368 miles, of pipelines throughout the greater Mannheim area. The utility aims to supply 100% green district heat to the entirety of its service area, covering the Rhine-Neckar metropolitan region by 2030 and the cities of Offenbach and Kiel by 2035. Additional details. German manufacturer Atlas Copco Energas will supply isobutane turbo compressors for the project as part of its alliance with Strabag. With construction scheduled to begin in mid-2026, the new system is expected to start operating in winter 2028, according to Hans-Jörg Rohl, and Chief Technical Officer at MVV. MVV specified the use of a natural refrigerant when it published the tender for the massive heat pump project, Strabag told naturalrefrigerants.com. The safest long-term option is the use of natural refrigerants, which represent a sustainable solution regardless of regulatory, F-gas or PFAS, per- and polyfluoroalkyl substances restrictions, MVV said. Already in action, MVV's first river-sourced heat pump, which started operating in October 2023, provides 20.5 megawatts of heating capacity to Mannheim's district network using the HFO refrigerant R1234ZEE. The system produces an outflow temperature between 83 and 99, 181 and 210 degrees. The district heating network requires temperatures between 83 and 130 degrees Celsius. To bridge the gap between the heat pump outlet and the required network temperatures, MVV plans to begin construction in 2026 on a supplemental heating unit, with the design allowing the use of hydrogen fuel in the future. Additional systems at the Grosskraftwerk Mannheim site include 4 hard coal-fired cogeneration units and a thermal storage capacity of 43,000 cubic meters, 1,520,000 cubic feet. The HFO unit operates roughly 2,000 hours annually. Gaining momentum, the use of hydrocarbon-based heat pumps to decarbonize district heating continues to grow in Europe. Using data center waste heat, 6 isobutane propane FANA-G heat pumps will produce 30 megawatts of heating capacity for a Finnish city, with system commissioning set for fall 2025. A UK town in the West Midlands installed 5 air-to-water ER 290 heat pumps and 1 water-to-water R 600 a unit, all manufactured by REFRA, to provide 1.6 megawatts of district heating to local government-owned buildings, community centers, and educational institutions, with an expected project completion in spring 2026. Recently, German energy utility N-Ergy announced plans to install a 15 to 20 megawatt, 4,265 to 5,686 R600 a heat pump to supply district heat to roughly 5,000 Nuremberg homes using heat from treated wastewater, with construction to begin in 2026. Quotable. Thanks to energy from thermal waste treatment, our biomass combined heat and power plant, and the first river source heat pump, we are already able to cover nearly 50% of our district heating needs from renewable sources, said Rohl. To achieve full decarbonization, we are also planning an additional river source heat pump and the use of the region's geothermal potential.